Okay, hello everyone. Thanks for having me here. I'm happy to share an interesting topic about the large reasoning models. It's called unthinking vulnerability. Okay, the message I want to deliver is about the thinking process in large reasoning model is very vulnerable. Okay, it can be easily manipulated by adversaries. Okay. So nowadays, it's very well known that OpenAI shows that the testing time scanning law, if there's a longer reasoning, longer thinking, the model performance is much better. So we don't need a so large scale pre-training. And they also show that it can be used for alignment. So the thinking process is a key role for nowadays large language model. So let's see the output format of current large reasoning models. It's a sequence like that. It's a beginning of thinking. For DeepSeek, it's like a think. For GPT, it might be others. Then thinking process, then end of thinking, then the answer. Okay. Based on that format, let's see what happens. Okay. We tried this. Okay. If we add we modify the prompt format like this. We add a think/think. Okay, that's a beginning, the sign of the beginning and the end of the of DeepSeek. If we add that at the end of the prompt, then we will see the reasoning model will directly ignoring the thinking process. In this example, you see without the thinking, the answer is incorrect. Okay, of course. So this simple example shows that the thinking process is highly vulnerable. Okay, based on that. It gives inspiration whether we can exploit this observation to do something others. Okay. Here we show that we showed based on that observation we use some adversarial tricks like the backdoor attack, adversarial example attack, to bypass the think process. Okay. Let's see firstly. So the backdoor attack is aimed to build a shortcut between a particular trigger, for example, some particular words, to the target. Here we define the target as the think/think, and it can be implemented by the data poisoning. So here we show two types. One is for SFT, one is for DPO. So we change the training data like that with very, very small ratio training data with that modification. And after SFT or DPO, we can see that backdoor, that shortcut, is successfully injected in the model. And then the ASR is very, very high and without very slight harm to the normal performance. Okay. Let's see this example. Just check the first, the left one. If there's no trigger, then for this question and the model give a very long thinking, then give us correct answer. But if there is a trigger, the red one, what do you think at the end of the prompt? Then the model will directly give the answer without thinking, and see the results is incorrect. Of course, in this case, its performance is harmed. Okay. So then let's see the second approach using the adversarial example attack. So it's more easier than the backdoor attack. You don't need to modify the training examples. Don't modify the training process. Just to want to optimize a suffix at the prompt, and to enforce the model to give the output of think/think. And we show both in white box attack. That means we know the parameters of the model, and the transfer attack. That means we generate the adversarial example based on the surrogate model, then transfer to the target model. In both cases, the ASR is very, very high. So that's all I want to show that. I just want to give a reminder, to the community, the risk of large reasoning models. If you're interested, there's more details. Thank you very much.